All right, welcome back to the Dave and Molly podcast.
Always a pleasure to be here.
We like to keep things fresh and fun around here, dive into whatever's trending, whatever's got people talking.
That's right, keeping our fingers on the pulse.
Exactly. And,
Okay.
it's no secret that one topic has been absolutely dominating the headlines lately.
Yeah, it's everywhere you look.
Artificial intelligence, AI.
AI, yep.
Now, we asked you, our awesome listeners, to send in anything and everything you can find on AI, articles, videos, whatever sparked your curiosity.
And they delivered.
Oh, they did. TED Talks, breaking down the basics, think pieces on how it's going to change the way we work, even deep dives into the tech behind self-driving cars.
A real smorgasbord of AI insights.
It's a feast, and we're ready to dig in.
Let's do it.
So our mission today is to cut through all the hype, all the noise.
Separate fact from fiction.
Exactly, to understand what AI really is at its core, how it actually works, in a way that anyone can grasp.
Without getting lost in the technical jargon.
Right, and then we're going to explore what AI can do for us, the good, the bad, and yeah, even delve into some of those, frankly, kind of scary aspects that some of you brought up.
Some fascinating and perhaps unsettling possibilities.
So let's start with the million-dollar question.
Hmm.
What is artificial intelligence, really? I mean, we throw that term around so much.
It's become a bit of a buzzword.
Right, but what's the essence of it?
Well, one of the sources you sent in defined AI as essentially the quest to create machines that can, think and learn like we do.
Mimic human intelligence.
Exactly.
So we're basically talking about trying to build a brain, but out of circuits and code instead of neurons,
A digital brain.
which is mind-blowing when you really think about it.
It is. And the way these digital brains learn is through something called machine learning, which is a core concept in AI.
Machine learning. All right, break that down for us.
Okay, so imagine you have a giant pile of pictures, millions of them, of cats and dogs.
Yeah, I'm picturing it.
And you go through and label each one cat, dog, cat, dog.
Gotcha. So you're teaching the computer the difference.
Exactly. You feed all that labeled data into a computer program, and it starts to identify patterns.
It's like showing flashcards to a kid.
Sort of. The computer builds a model in its digital brain, a way of recognizing the characteristics of a cat versus a dog.
So then when it sees a new picture, it can predict, hey, this is probably a cat based on what I've learned.
That's the idea. That's supervised learning, where you give the computer labeled data.
So what about unsupervised learning?
Well, in that case, you give the computer data without any labels.
So it's on its own.
It has to figure out the patterns itself, like grouping customers together based on their purchasing habits, even though you haven't told it which customers are similar.
So it's finding connections that we might not even see.
Exactly.
Okay, now this is where it gets really interesting for me. We have this thing called deep learning,
Ah, yes, deep learning.
which takes machine learning and, well, cranks it up a notch.
It goes deeper, as the name suggests.
Right. It uses these things called artificial neural networks, which sounds super complicated.
They are inspired by the structure of the human brain.
So it's like a much more complex version of our cat and dog example.
You could think of it that way. Instead of just looking at a few obvious features, deep learning examines many, many layers of information, kind of like how our brains process things on multiple levels.
So it's making connections upon connections.
Exactly, extracting meaning from those intricate patterns.
One of our sources gave this really cool example of a bank using deep learning to spot fraud. They labeled just a tiny handful of transactions as fraudulent, and then the deep learning model could take that little bit of labeled data and sift through a mountain of other transactions.
Unlabeled transactions.
Right, and flag anything suspicious.
So it's extrapolating from a small sample to a much larger data set.
Pretty powerful stuff.
Indeed.
Now, we can't talk about AI without talking about these rock stars of the AI world, the LLMs,
The large language models.
like ChatGPT and Google's Gemini.
Right. These are the models that have been making headlines, generating text, writing poems, even composing music.
Yeah, it's wild. But how do they actually work? I mean, is it really magic?
Not magic, but it's pretty close. One source described an LLM as essentially a very sophisticated mathematical function.
Okay, so math is at the heart of it.
It is, and what this function does is predict the next word in a sentence.
It's like a super-powered autocomplete.
Kind of. It looks at all the words you've typed and then assigns a probability to every possible word that could come next.
And then picks the most likely one.
Usually, but sometimes, to make the text sound more natural and less robotic, it'll deliberately choose a less likely word just to throw in a little bit of variety.
That's so clever.
It's like adding a touch of randomness to mimic human speech patterns.
So how do these LLMs get so good at predicting the next word? I mean, they seem to know so much.
Well, they've been trained on an unbelievable amount of text, scraped from the internet, books, articles, code, you name it.
We're talking more text than any human could possibly read in a lifetime.
Absolutely. And during this training process, they're constantly adjusting these internal settings called parameters or weights.
Parameters, weights, it sounds so technical.
Think of them like tiny knobs inside the model.
Okay, tiny knobs.
And with each piece of text the model reads, these knobs get tweaked a little bit, making it better at predicting the next word.
So it's like a self-tuning instrument constantly refining itself.
Exactly. And some of these models have hundreds of billions of these little knobs.
Hundreds of billions, wow.
And an algorithm is constantly analyzing the data and making tiny adjustments to those knobs, trying to optimize the model's performance.
That's incredible.
And then, on top of all that initial training, many of these chatbots go through another stage called reinforcement learning with human feedback.
So humans are still in the loop.
We are. Real people look at the AI's responses and give feedback. This was helpful, this was off topic, this was just plain weird.
And that feedback helps to further refine the model.
It does. It's like giving the AI a performance review.
And all of this training, all this fine-tuning, it takes a massive amount of computing power, right?
Oh, yeah. We're talking industrial scale computing, which is why they use these specialized chips called GPUs, graphics processing units, originally designed for video games, but perfect for the kind of parallel processing that AI needs.
So the gaming world actually helped to accelerate AI development.
In a way, yes. Those GPUs can handle the massive number crunching operations that AI requires.
Okay, so we've talked about machine learning, deep learning, LLMs, neural networks, parameters. It's a lot to take in.
It is a lot, but hopefully we're starting to get a glimpse of how these systems work under the hood.
Right, because ultimately what matters is what all of this means for us, for our everyday lives.
How AI is going to impact the world.
And your source has really highlighted both the incredible potential of AI and some serious concerns.
Two sides of the same coin.
Exactly. So let's start with the good stuff, the ways AI is already making our lives better. I mean, AI is being used to discover new medicines. It's powering features on our smartphones that we use every day.
AI is the invisible force behind so much of our technology.
Right. And of course, we've talked about self-driving cars, which are heavily reliant on AI.
And that's just the tip of the iceberg.
One of the sources pointed out that AI can now help people create music even if they have no musical training.
AI as a creative collaborator.
Exactly. Same with video editing. AI can assist even those who aren't videographers in creating professional-looking videos.
Democratizing creativity.
And it doesn't stop there. AI can help with coding apps, building websites, even suggesting recipes based on what's in your fridge.
Personalizing our digital experiences.
Oh, and let's not forget about taxes. AI can analyze complex financial data and help you file your taxes more efficiently.
Taking some of the headache out of tax season.
And the potential for AI to help us discover new cures for diseases is huge.
The medical applications of AI are incredibly promising.
There are even some economic forecasts that suggest AI and robotics could add trillions of dollars to the global economy in the coming years.
That's a significant boost.
Right. And we even have AI-powered apps that can help us learn more effectively, creating flashcards, mind maps, summaries from our lecture notes, videos, articles.
AI as a personal tutor, tailoring education to individual needs.
And of course, self-driving cars, if they live up to their promise, could make our commutes safer and more efficient, potentially reducing traffic jams and accidents.
Transforming the way we get around.
So it sounds like AI is going to solve all our problems, right?
Well, not quite.
Because your sources also raised some serious concerns about the downsides of AI.
Potential pitfalls we need to be aware of.
One AI researcher even shared an email they received expressing fear that their work would lead to the end of humanity.
The existential risk of AI.
Yeah, that's pretty heavy stuff. And while those kind of doomsday scenarios are still debated, there are some more immediate, tangible impacts that we need to address.
Real-world concerns that are already starting to emerge.
One of the biggest concerns is the energy consumption of these massive AI models, the amount of computing power required to train them.
The carbon footprint of AI is significant.
One study found that training a single large AI model could use as much electricity as 30 average homes consume in a year.
And emit a substantial amount of carbon dioxide in the process.
Which is a problem if we're trying to address climate change.
It raises questions about the sustainability of AI development.
And what's even more concerning is that these environmental costs aren't always being tracked or made public by the companies developing this technology.
A lack of transparency,
Right, so we don't even have a clear picture of the full environmental impact.
which makes it difficult to address the problem effectively.
Another major issue highlighted in your sources is the data used to train these AI
The
models.
fuel that powers AI.
A lot of this data includes creative works, art, books, music, created by artists and authors who never gave their permission for their work to be used in this way.
Raising questions about copyright and intellectual property rights.
Right, and this has led to a number of legal battles over copyright infringement.
Artists and creators demanding recognition and compensation for their work.
And then there's the whole issue of bias in AI, which is a huge concern.
Bias baked into the algorithms.
Because if the data used to train AI models is biased, then the AI itself can perpetuate and even amplify those biases.
Leading to unfair or discriminatory outcomes.
We've already seen examples of this with facial recognition systems that are less accurate for people of color.
And biased AI models used in law enforcement can lead to wrongful accusations and convictions.
AI can also generate images that reinforce harmful stereotypes based on the search terms used.
So it's crucial to ensure that AI is developed and deployed in a way that is fair and equitable.
And then there's the question of what happens to jobs as AI becomes more sophisticated.
The future of work in the age of AI.
Some experts predict that AI and automation could displace a significant number of jobs.
Some estimates suggest that up to 40% of jobs globally could be affected in the next 15 years.
Jobs in transportation, customer service, and many office jobs that involve repetitive tasks or data analysis are seen as particularly vulnerable.
So we need to start thinking about how we prepare for these potential job losses.
Right, and while new jobs will emerge, the transition could be difficult for many people.
Especially those who may not have the skills needed for these new roles.
And then there's the whole issue of AI in weapons technology, which is frankly terrifying.
The potential for autonomous weapon systems.
AI-controlled drones, even swarms of tiny, inexpensive assassin drones.
And with the technology already existing, it's not a far-fetched scenario.
And then self-driving cars, while they offer potential benefits, also raise concerns about job losses for drivers, liability in case of accidents, and even the potential for misuse.
So it's important to have these conversations now and consider the ethical implications of AI development.
Because AI is not some distant future technology. It's here, it's now, it's already woven into our lives.
And it's evolving rapidly.
So the question is, should you care?
Should our listeners care?
Absolutely.
Yeah.
Because understanding how AI works, its potential benefits and risks, is crucial for all of us.
We are all stakeholders in the future of AI.
The choices we make now, as individuals, as a society, will shape the impact of AI on the world.
One of your sources put it well. We are building the road as we walk it.
And we need to decide collectively what kind of road we want to build. One that leads to a better future or one that leads us down a dangerous path.
It's a shared responsibility.
So as you can see from this deep dive into AI, it's a complex landscape.
Full of both incredible potential and significant challenges.
From the intricate workings of neural networks to the broad societal implications for jobs, the environment, even the future of humanity, AI is a powerful force.
A force that we need to understand and shape.
And it's moving so fast, some experts suggest we could see truly transformative changes within the next 5 years.
An accelerated pace of innovation.
Which makes it even more important to consider not just the technology itself, but the ethical implications.
The values that we embed in AI systems.
We need to think about the balance between convenience and environmental impact.
The trade-offs between efficiency and fairness.
The implications for creative industries and intellectual property rights.
The need to prepare for potential job displacement and the rise of new industries.
And most importantly, the ethical guardrails we need to ensure that AI remains a tool for good.
A force that benefits all of humanity.
So this brings us to a crucial question for you, our listener. As AI becomes more integrated into our lives, what role do you see for yourself in shaping its development and deployment?
How can we collectively ensure that AI serves our best interests?
What kind of conversations and actions are needed to create a future where AI enhances our lives, solves problems, and minimizes potential harms?
It's not just up to the researchers and tech companies. We all have a role to play.
Your understanding, your voice, your choices matter.
Thank you for sharing those incredible sources and for joining us on this deep dive into the world of AI.
We hope this conversation has sparked your curiosity and given you some food for thought.
Keep exploring, keep asking questions, and keep the conversation going.
Because the future of AI is ultimately up to all of us.
We are writing the next chapter together.
And on that note, thanks for tuning in.
Until next time.
Catch you later.